Hello, chemistry students. I want to take a moment and go over with you what we're going to be discussing in this unit. Essentially, this unit is called quantum mechanics, but I didn't name it that because when you hear quantum mechanics, it sounds very intimidating, or at least it did when I started learning about this. But essentially, what quantum mechanics is just quantum is something very small, and mechanics is how it functions. And so what we're really learning is how electrons function and provide us the electromagnetic spectrum. So I'm going to go over, this is the North Carolina standards that you see on your screen, and we're going to focus this particular screencastify on the wave-particle duality of electrons. So in other words, they can act as a wave or as a particle. So I'm going to provide you some lecture notes for this that's going to be attached. You're kind of looking at the background behind the scenes of how I build a module. So you'll see that, and you'll also have a pacing guide provided here. So let's go over here. Go to the next page. Okay, so the first question is light a wave or is it a particle? And we already know that they're both. So I want you to take a moment before we get in depth, and I want you to either take a picture on your phone or just screenshot a picture on your Chromebook and just keep on hitting zoom. Zoom in, zoom in, zoom in until all you see is particles. You're going to see blocks, essentially. It becomes pixelated. So there was a guy named Planck, and he said that if you continue to zoom in close enough, that things don't blend in. They don't move smoothly. And so how small it goes in order to see these pixels is this number right here, 6.626 times 10 to the negative 34. Super tiny. And I have added a video that kind of discusses that as well. So if you take his concept that if you continue to zoom in things very, very closely, they become pixels. If you take that concept and you apply it to light, you're going to see photons. And photons is a very small package of light. So this is where we get the terms photography, photosynthesis, and this is where Albert Einstein come in. And Albert Einstein said that light can be both a wave and a particle at the same time. And I'm going to give you a video right here. It's a photoelectric effect. And you're going to also do a lab a little bit on in the module involving this. So essentially, I've given you a picture of what Albert Einstein meant. So each particle is going to be moving in a wave-like pattern. So just like in the ocean, you have your crest, you have your troughs. Light also travels about that in that direction. And so this is the wave-particle duality, meaning that light is both a wave and a particle. So before we go any further, and before we start exploring what electromagnetic waves are, let's research what a transverse wave is. Okay, so remember, a transverse wave is just like in the ocean, just like we've pictured here. So I broke down a transverse wave into the anatomy of it. So again, we talk about the crest. That's the top parts. We're more familiar with that because we've gone to the ocean. The troughs are the lower part. The amps are the height of the wave. And then we scroll down to wavelength and frequency. Now, frequency is very, very important. So I want you to spend some time watching this video, and if you have to, watch it more than once to understand the frequency. Because it's very important that you know that there is an indirect relationship between frequency and wavelength. So the faster the frequency, the smaller the wavelength. So again, I'll say it again. The faster the frequency, the smaller the wavelength. And again, the slower the frequency, the bigger the wavelength. Okay? So I will provide step 2 in just a moment.